Right. Hello, everyone. Let me move some stuff around. Okay. I'm Professor Caudill, and today we're going to do some practice. We're going to do some problems. So we've done this one. I skipped this one because I just don't like how it's worded. Plus, I don't golf, so. Bird flies northeast. Kilometers an hour. T is 3. Okay. What is a displacement vector? So guessing what they mean by straight northeast is a 45-degree angle. Okay. So yes, we did this yesterday. So we got 67I, 67J. So and what number is this? 20. Okay. I don't think the book does 20. Yeah, okay. All right. What's average velocity? So we can do this, but I think the book wants us to use this. So I'm thinking divided by 2. So it is it is the same thing, just written differently. So we're gonna get about 33 J average velocity. Okay, so that's 20. I should get in the habit of writing a little bigger. I feel like it'd be good for the viewer. 5 east. So 5. Okay, so R1 is 5. I R2. These are position vectors. Okay, so this one we're gonna have to convert into components. So this is 10 cosine, 20 west of north. It's 110. That'll be our I. plus 10 sine 110j. R3, we don't. So delta R. Okay. So easy enough. Seems to be review for the most part. So it's going to be negative 3.4 plus 9.4 minus 5. Okay, so that's going to be negative 8.4 plus 9.4. Okay, so let's see if the book got that. 21. They're getting 6.4. 6.4. Okay. Okay, so I missed this point. I totally skipped this line. All right, my bad. So this is delta R1. Let's say R3 is negative 8 pi. So that would be 0.4. It's 944J. Doesn't seem right either. Okay, so they're doing a sum of displacements. Don't think that equation. Oh wait, I don't think it's here. Delta R. I think they have it. They have this equation somewhere else. Yeah. So this is what they didn't include this. So Okay. I don't think we need the magnitude. I think they just want it like this. So we're finding delta R total. So R1 is 5. So maybe it should be negative 5i minus 3.4 I. Okay, so this might be delta R2. And then we're adding this to this minus 5. Okay, so should be so negative 5 plus 3. Negative 5 plus 3 is 2, 1.6. And that would be minus J. Okay, now we're going to add this to negative 8.4 minus 9 point. Okay. So here we will get 'so that's not right either. Okay, this is on page 6. And okay, maybe I think I might understand what's going on here. So we're going 5, and then we're going 10. So we want to know what this is. Maybe. I think the arrow will be going this way. Well, okay, so we know this angle is 110 degrees. So it's going to be do we add, maybe we add this. So when I did 10 cosine 110, this might be assuming it's at the origin. But if it's already 5, maybe we try. Maybe we try. No, we can't do Pythagoras theorem because it's not a right angle. Okay. All right. 5 east, 8 west. I guess you could sit. No, it's still not a right angle. It's really making this tough. So let's just retry. R1 is 5 cosine 0 plus sine. Pi R2 Is it 10, 110, or is it 15, 110? 8.429. We've gotten that before. 3.4 and 9. Okay. What if it's 15? Okay, well, we cut the triangle this way. I want to give us a right angle either. If it's this way, you might have a triangle. Then 10 is the hypotenuse. Let's say it's 5 here. I don't know if that's what we need though. I'm thinking it's so like this would be from the origin, but we already started at 5, so it would be here plus 5. So shouldn't it be 2.4? Did I already do this? Okay. Okay, so delta R1 is going to be 2.4 minus 5. Okay, so that's going to be negative 3.6. Negative 2.6. Okay, now we want to find delta R2, so we're going to take, first we're going to write down R3 is simply negative 8I, so delta R2 is negative 8 minus 2.4 I. Okay, so that's going to be negative 10.4 I. Okay, so then delta R total would be this plus this. So I'm getting 12, I'm getting negative 13. Which is not what the book's getting. Okay, let's see if... Alright, so let's try to get a different opinion. 20 degrees. West of north is 10 degrees. You swap the sine and cosine function. Okay, so it's getting this. Three 3.4, 9.4. Okay, so I don't think that's what they want. They want the I mean, I guess I could convert it into that. Okay, so we know from our calculator 10 cosine this is this, so you know R1 R2 is like 3.4 plus 9.4. Okay, that's what this is getting. Okay. So it's adding these up together. So it's so they're getting they add these. So we can see this is negative 11 plus 5. That's 6.4. Negative 6.4. 9.4J. So I mean that matches what the book's getting. Doesn't really make sense as far as how the textbook was directing me. As you can see, I thought you had to do like delta R for displacement. I mean, that's what the question is asking. What's the final displacement? So, uh, yeah. I guess I mean, I guess I should know like these vectors are already in displacement form. So, sound like they were in functions. I don't know. All this is not necessary yet. Like, we could do it. Hmm. It's like, how do they want, like, okay, so, yeah. The book was expecting just unit vectors. So, yeah. Language model is doing a little bit extra there, I guess. 22. So let's see if we can use our 45 degrees from. Let's see if we can just see if we can extract the knowns. Oh, where is it? 20 degrees. So final displacement of the puck. Okay, so he's passing it to this guy, right? Passes it 20 meters from straight down the ice to the left wing. Okay, so he's coming this way. He wants to meet him there. Is that what I'm saying? He's waiting at the blue line. Passes it to him. So this is his current position, and he's trying to move it here. He's trying to predict where he's going. Okay, what's the displacement of the puck? Okay, so I think we could extend this. I think we could extend this. So this would be 45. This might be useful, might not. So then this would be 45. This would be 180. So this would be, so this total would be 90 plus 45, 135. I don't know if that's relevant here. Okay. So we need to find this position. So I know the first thing we're gonna find is we're gonna say this point is R1. Well, I guess we should say here is R1. And then we could say here is R2 something. So we're gonna say R2 is so we're gonna do maybe inside this above. No. Sell, edit, move, sell up. Okay. So I want to do 20 at 45 degrees. So 14i plus j. Okay. So let's say R3 is 14 minus 10. Okay. So that's going to be 4i. Okay. So this is R3. So I think that's the answer. Yeah, I'm happy to move on. Okay, so we're given a position function. So we want to find b at 0. And v1, and then we want to find v average at so these are what we are finding. Okay, so dr is going to be 8t I plus 0 j plus 6t squared meters. Okay, so now that's our V. Okay, so V0 is 0. V1 is 8I plus 6K. Okay, so they want the average, so it's going to be 8I plus 6K over 1. So our average velocity is the same as our velocity at 1 second. 23 8I plus 6K. The average is 4. They do the 2. So this is, I mean, it's kind of annoying because I'll show you why. I'll show you why. The book says average velocity is T1 minus T2. Okay. So T2 is 1, T1 is 0. So it should be 8I. Should be how I did it. But then, you know, from earlier chapters, you've seen this, where you have your initial velocity, and that's divided by 2. So I don't know how to reconcile these. Hmm. Okay. Maybe we should be doing so this is R of T, not so this is I did V. This is R of 1 minus over 1. Okay, so it should just be, so average velocity should be 4I 3J minus 2K at okay. 4I plus 2K. But they're getting, they're still dropping off the J. This doesn't seem, it doesn't, I feel like the books made a mistake here. Okay, well, think about it like this. It's going to be this minus 3 j because of this. So this will be 0 through j. So then these cancel out. Okay, so that will get us there. That's a good problem. I'll say that's a good one. All right, 24. I'm sorry, 23. 15 minutes. So position particle. Nope, we just did that. I'm sorry. All right. We have a runner. He can go up to 10 meters per second. Okay, so start of the play. So running 45 degrees. So V of 1 second. Or do I say? Do I say R? R in 1 second. Elapsed time. I don't know what that means. Elapsed time, is that just, so would that be 2.1 seconds? Or 2.2 seconds. Okay, is 12. Because they want to find his final displacement. They want to find this. What is... They want to find this. Okay, so... He can run 10 meters per second. He can, but he doesn't. So basically, can't exceed 10 meters per second. Okay, so if this is our T1 is 0. Okay. And then we say this point is our and then this point is R T3 minus R T2. Okay. So we're going to say T2 is 1 second, T3 is 2.2 seconds. Okay. So we find this, so it should be 8. Okay. And then he runs 12. So this should say, I should say delta R1. Okay. And then we do T3, so that's going to be straight north, so it will be 8 J, so it will just be it'll be 0 minus 5.7 I plus 8 minus 5.7 J. So delta R is okay, so now we sum the delta R's. So we will get 8J. Doesn't seem right. 23, 8J. 24. Don't even have this one. Hmm. Man, I really don't want to end it without solving this. Like we know this point, we know this is 5.5. Like wouldn't this just be 13.57? So wouldn't this just be 8 plus 5.7? So that would be 13.7 I plus 5.7 J. Then the total displacement should just be should just be 19.4 I plus 11.4 J. All right, if I'm gonna give you an answer, it's this 19I 11.4 J. So I just took I took this point in unit vector notation. I added it to this to find this point, and then to find this, I took this plus this. Might not be right, just saying. But yeah, next time we'll pick up on 2025. So I'll see you. Have a good one.